This second problem is just like the first problem, but there is one difference. We're going to direct our 200 Newton force downwards at an angle of 30 degrees. So the free body diagram is going to be a little bit different. Let's go ahead and draw that now. So we still have the point that represents our desk. We're still going to have the normal force. We're going to have a weight pointing downwards. We're going to have a friction force, and I'm just going to do something here. I'm going to draw the downward force of 200 newtons like this, that F. And what's going to happen here is I'm going to draw a little dotted line because there's something we need to actually look at. This is directed downwards at an angle of 30 degrees. Now, what's going to happen in this problem is that we're going to go ahead and split this force F into an X part and into a Y part. Whenever you have a force at an angle, you actually have to do that. So let's take this force, and I'm going to have an Fx, and I'm going to solve for an Fy. And so you see in the X direction we have F and Fx canceling. And in the Y direction we have N, W, and Fy. So when we write the equation in the X direction, we're going to write Fx and friction, the static friction balance. So that might make sense. And we're going to actually calculate this in a second using our trig. And in the Y direction, it's a little bit different. You see, I have W and I have Fy. So once you split the force into pieces, we don't actually use this in the equations. And so in the Y direction, we're going to have N. Because it's going upwards, we're going to make this a positive force. And all the downward forces, we're going to write as negative. So N minus W minus Fy equals 0. Let's determine the value of the frictional force. So Fx is going to be 200 newtons, but now I have to times it by the cosine of 30, going back to that formula. If you remember, if we have F at an angle of theta, Fx is F cos theta, Fy is F sine theta. And so what we're going to end up getting for Fx we end up getting 173 newtons. And that's exactly equal to our frictional force. Now we want to go ahead and calculate the normal force. So to do that, I actually need to get Fy. So I'm just going to go ahead and use this formula to get Fy. So Fy is going to be 200 times the sine of 30. Sorry about the bad handwriting. And that's going to end up being 100 newtons. So now I'm going to plug that into this formula here. So I'm going to get N minus the weight, which we calculated above as 490 newtons, minus 100 newtons equals 0. So I'm getting a normal force of 590 newtons. Now, let's go ahead and get the coefficient of static friction in this case. So the coefficient of static friction, I'm going to use Fs equals mu static times the normal force, and that's going to work out to be here 173 equals mu static times 590. And when we work that out, we're going to get mu static equals 0.29. So these are two example problems. You're going to have a couple Google Docs questions that you need to answer in each of these videos. I'll be collecting those and seeing how you do.